I want to show you a little example for calculating future value, and I'm going to try and present it with a little different analogy to perhaps make it a little clearer, or perhaps not. Suppose you save $100 today, and then 2 years from now you throw another $200 in the bank, and we want to know, what is this going to be worth in year 4? Now, instead of thinking about it from a future value perspective, normally we talk about, well, you have to bring the first cash flow out to year 4, and then you have to bring the second cash flow out to year 4, because you can't add them up unless they're in the same time period. It's hard to think about time periods. Think about these as places. What you want is you want this to wind up in the same place as this. And there are a number of ways you can do this. So let me do a couple of these. All right, and I'm not a very good artist, so I don't know how good this will look. We're going to use an interest rate of 10%, but it should come out the same. Now the first way we could do this is we could have, and let me change the color of the pen here. All right, the first way we could do this is it's almost as if you're driving. Okay, so we got a little car here, and so this is the $100, and this 100 drives all the way out to year 4, and then we've got another car here, with 200 in it. Sorry, you can't see that 0, and it drives out here, and they meet and they get together in year 4. So if you wanted to calculate the future value using that approach, the future value here would say it's 100 times 1.10 plus 200 times, 100 times 1.10 to the 4th power, because it's going a distance of 4, and the 200 is going a distance of 2. So let's see what we get here. We're going to get 1.1 raised to the 4th power times 100. So we're going to get 146.41 plus, and what do we have here? 1.1 raised to the 2nd power times 200. That's 242. And let's just add that to the 146.41. So we get 388.41. Now, another way we could do this is we could have the $100 meet the $200, and they could drive in together. All right, kind of a silly concept, I guess, but to show you that there are a lot of ways to do this, and we should get the same answer. All right, let me change my colors here. I'll try blue. All right, so in this case, this 100 is only going to drive to here. How much is that going to be worth? Well, it's going a distance of 2, so it's 1.1 raised to the 2nd power times 100. So that becomes 121. And now the two of them go together. And so 121 plus 200 is 321. So the 321, so it's kind of carpooling here, carpooling in finance, goes out to year 4. So it goes two more units. It goes a distance of 2, so that's going to be 1.1 squared times 321. So that's 388.41. So we get the same thing again. 88.41. Okay, so this was 321. I should have written that down first, times 1.10 squared. So you can see they can do it different ways. Let's do one more. Let's do one sort of where it doesn't really make sense from a traveling point of view, but how about if the $200 goes back to the 100 and then they drive together? So let's try this analogy. All right, let me pick another color here. So in this case, I'm going to have the 200. Oops, didn't change the color. Okay, here we go. The 200 is going to go back this way. So now we need to find present value. So this is going to be 1.1 squared, and we're going to flip that over and then multiply it by the 200. So that's 165.29. And then the two of these, so add that to the 100, so we're going to have what, 265.89? And then they're going to drive all the way out 4 periods. So if we take 265.89 and multiply it by 1.10, so the fourth power, because now they have to go a distance of 4. Seems kind of stupid, you know. This one backtracked. Perhaps this one had to pick up this person. This person doesn't have a car, so you have to drive backwards, pick the person up, and then go back this way. So let's see what happens. 1.1 raised to the fourth power times 265.89, and hopefully we'll get the same answer. 389.29. I'm a little off here. Did I put in the wrong number? Let me try that again. Let me make sure I did this correctly. It should really be a little bit closer than that. So let's take 1.1 and raise it to the second power. Then I'm going to take the inverse of that and then multiply it by 200. And I get 265. Oh, I put 89 here. It should be 28. See, there's where my problem is. So this should be 265.28. All right, so let's try that. 265.28. So this should be 265.28. All right, wait a minute. So 1.1 raised to the fourth power times 265.28, and we get 388.39 or 40. Okay, pretty close. I think I should have actually rounded this up to 29 cents because I think it was 28 and it was 9/10, another 9. So, you know, that's a lot closer. So it doesn't really matter how you get where you're going, as long as everybody winds up in the same place. So as long as this 100 winds up here and this 200 winds up here, it doesn't matter if they both go separately, if the 100 picks up the 200 along the way and then they go together, or if the 200 goes back and picks up the 100 and then they go all the way together. It doesn't matter. As long as they all wind up in the same place, which in this case is period 4 or place number 4. So perhaps that's a better way to think of it. Instead of thinking about everything has to be in the same time period, everything has to wind up in the same place. And hopefully that analogy will help you. I mean, we easily could have taken this all the way out to year 10 and then brought it back to year 4. Now, why would we do that? I don't know. Okay, maybe you can argue that there's a store here they had to go to if we're using this traveling analogy. But we could have taken these two taken them out to year 10, and then brought them back to year 4, still should get the same answer. So it really doesn't matter what direction you go in, how you move around, as long as you wind up in the same place and you've done the calculation correctly, you should get the same answer.